So for improper integrals, what I want to talk about today is if we are evaluating an integral and one of your limits, either a or b, is infinity. So if it's a, it would have to be negative infinity. If it's b, it would have to be positive infinity. So we just need a strategy for doing that because, of course, infinity isn't a number, so we need a workaround. So let me show you how it's going to work if, for instance, b is the positive infinity, right? So we would be integrating f of x dx from a, some number, to infinity. So what we're going to do is we're going to replace that infinity with an arbitrary letter. A lot of books use capital R. Then we're going to go about our merry way. We're going to find the antiderivative, and we're going to evaluate it top minus bottom. So capital F of R minus capital F of A. And then, right, because we really do want to know what happens when R is infinity, so we'll just take that limit as R goes to infinity. And we'll have to remember L'Hopital if it's applicable, right? And remember that means we need one of our indeterminate forms. Okay, so let's go ahead and do this example. 0 to infinity of 1 over 4 plus x squared dx. So you have to remember all of your integration techniques. So this looks like a trig sub. So we'd let x equal 2 tan theta. So that dx is 2 secant squared theta d theta. I'm going to go ahead and do my antiderivative without my limits, and then I'll bring them back here in a second. So I have 1 over 4 plus 4 tangent squared theta. Dx is 2 secant squared theta d theta. So now I have, let's see, that denominator, that's 4 secant squared. So I have 2 secant squared theta and 4 secant squared theta d theta. So of course those will cancel. So I'm integrating 1/2 d theta. So that's 1/2 theta. But theta, right, I need x's, so back here, so tangent theta is x over 2, so theta is inverse tangent x over 2. Okay, so I guess I didn't have a chance to switch my limit, so I'll go ahead and do that now. So it was 0 to infinity, so that's what's going to go here, back to x's, but instead of infinity, I'm going to go 0 to r. So now we'll just go ahead and plug in our limits then. So 1/2 times the inverse tangent of r over 2 minus 1/2 inverse tangent of 0. So right, inverse tangent, that will tell you the angle that leads to the argument as the ratio. So I kind of think of a backwards trig or a tangent graph. So here's my tangent between negative pi halves and pi halves. So what angle leads to a tangent of 0? Well, that's 0. So this guy here, grab a different color, that last term is just 0 this time. And now here I have 1/2 inverse tangent of r over 2. And I want to take the limit as r gets really big. So I have 1/2 times the inverse tangent of infinity. So infinity over 2 is still just infinity. So what angle has, right, a tangent value of infinity? And notice it's positive. So positive infinity, right, that y value, positive infinity, happens at the angle of pi halves. So this right here, the inverse tangent of infinity, is, is pi halves. So 1/2 times pi halves, pi fourths. Stand that up so you can see. Okay, so that's if the top is infinity. So let's do one where the where the lower limit is infinity, and we'll see what that turns out to be. So I was going to do one where we can use partial fractions. So if the lower limit is the infinity, so negative infinity to 0, let's do a parts here, x e to the x dx. So we will let u equal x, dv is e to the x dx, so du is dx, and v is also e to the x. So I'm going to go between, let's see, what do I have? X e to the x minus the integral of v dx du, x e to the x minus e to the x. Okay, so here's my negative infinity, so I'll do r to 0. So we can go ahead and evaluate. So I'll plug in 0 first, right? Top minus bottom. So I have 0 e to the 0 minus e to the 0 minus r e to the r minus e to the r. So 0 times, that's 0. E to the 0 is 1, so I've got negative 1. I'm going to go ahead and take my negative sign through here just because I can. So minus r e to the r plus e to the r. So let's go ahead and try to evaluate. So we'll go ahead and take the limit as r. This time it's going to negative infinity. So now I have negative 1. So I'm plugging in negative infinity. So I'm going to get plus infinity e to the negative infinity plus e to the negative infinity. I know I'm treating it like a number here. It's an idea of a number, right? Okay, so now let's think about what those ideas of numbers are. So negative 1, that's just negative 1. It's going to keep tagging along. This middle one, that's going to be kind of an issue. So what do I get? I get infinity over, so e to the negative infinity is, right, e to the infinity on bottom. And then this guy here, that negative infinity will be 1 over e to the positive infinity. So this 1 over e to the positive infinity, so that's 0. This guy here, right, this is an infinity over infinity. Okay, well, that's kind of cool because this is our L'Hopital term. So now I'm just, right, I'm kind of piecing my limits together. I'm going kind of term by term. So the limit of the constant didn't change. The limit of that last term is 0. So now I'm just kind of focusing on this term right here, this minus r e to the r. So in order, so I can get it to be this limit, but it's not that way when it just looks like, well, I guess it is, isn't it? So I'm going to go ahead and rewrite that guy as, so I'm taking the limit, I'm just working on that middle term now. The limit as r goes to negative infinity of negative r over e to the negative r. So that's going to give me, I just want to make sure I still have L'Hopital here. So that's infinity on top. E to the negative infinity is e to the positive infinity. Okay, that is infinity over infinity. Okay, so then we can L'Hopital this guy. So since that's an indeterminate form, we can take the limit as r goes to infinity. So derivative of the top, negative 1, derivative of the bottom, negative e to the negative r. So that we get negative 1 over negative e to the negative infinity oh wait, that was going to negative infinity, wasn't it? So now I actually going to positive infinity. That's good. I needed that to go away. So I have, right, the two negatives will make it positive. So I have negative 1 over negative e to the infinity. So that's negative infinity. infinity on the bottom, constant on the top. Oh my gosh, that's a 0. So all of this, right, let us get up here. So both the last two terms both go to 0. So my limit, my integral, is -1. So all the way back up here to the beginning, the integral from negative infinity to 0 of x e to the x is -1.